Hello students, welcome to my classroom. In this video, we are going to talk about the concept of graphing exponential functions. This is also the very first video about exponential functions. So in this, I'm going to discuss basically an overview or introduction to exponential functions. So before we start, you really need to remember that, sorry, I need to deselect the line feature here and select the pen. So I hope I'm doing it correctly. Let's see. No, I guess not. All right, I think I fixed it now. So hopefully my writing should work this time. All right. I know you're laughing at me. It's okay. You can. Just for fun, I said that. So our question is y equals 2 to the power of x. Now, something that we need to remember for questions like these as students that your x is in the exponent. So these are those type of functions where your x, your variable, is a part of your exponent this time. So all right, we have started with a very basic function and we'll see the type of graph we will get. So we'll have our x and y, and this is our x-axis, and the standing axis is our y-axis or f of x. Y is nothing but a function of x, so we can write it that way as well. Now, what if I take x as 1? Now for x as 1, I will have 2 to the power of 1, which is 2. So that means the point of intersection here is 1 and 2. 1 and 2. I can plot that. Next up, what if I take x as 2? If x is 2, I will have 2 to the power of 2, which is 4. So my point is 2 and 4. 2 of x, 4 of y. Almost double this distance up. All right, next up I have 3. 2 to the power of 3, which is, we are actually making 2 multiplied by itself 3 times. So it's going to be 2 times 2 times 2, which is 8. So my point is 3 and 8. 3 of x, 8 of y. You see how it's increasing? Like till now, you must be thinking it's a linear or linear function, but it's actually getting a curve to it. And we'll see how that goes on. Now we have had a couple of positive values. Let's take a 0 value, a neutral value. So what happens when x is 0? 2 to the power of 0. Students, remember this like a times tables or important formula. Any number to the power of 0 is 1. So when x is 0, y is 1. So 0 of x, 1 of y, somewhere here. Negative 1. When x is negative 1, 2 to the power of negative 1. Now students, remember, whenever it's a negative power, 2 to the power of negative 1 is nothing but 1 over 2. We actually bring it down and make the power positive. 1 over 2 is nothing but 0.5. Half. Half a dollar is 50 cents. So 0.5 is somewhere here maybe. All right. Next up, I have negative 2, 2 to the power of negative 2, which is same as 1 over 2 to the power of positive 2, all or 1 over 4. 1 over 4, if a dollar has 4 equal pieces, I'm looking at one piece of a dollar or 25 cents. So 0.25, I'll graph it somewhere here. So as you can see on the negative numbers, our answer is still a positive number for y. And we can graph it something similar to this. So from very small values, it's coming up and the values are increasing exponentially. And these type of functions are called exponential functions, where something is either increasing or decreasing exponentially. So for increasing, like over here, it's increasing. So we can see, okay, well, in real life, what all things could be increasing exponentially? Money. For that, you don't have to be a teacher. if you want your money to be exponentially increasing. I'm just kidding. Next up, what could be increasing exponentially? Population of a place can increase exponentially. So, students, remember it's not a linear relationship, it's an exponential relationship where a small change in x gives you considerably large change in y. So, hope this made some sense. I have also graphed the same function on Desmos, and that's what I'm going to show you here. So, you can see over here that I typed in y equals 2x. And here is my function. I'm trying to zoom it also for you. And as you can see, students, that this line, we think that it's actually crossing. It appears that the line is crossing the the x-axis, or it's going to touch the x-axis, but it's not going to. It just seems as if it's actually touching. But as we move on to the negative side of the x-axis, the value of y becomes considerably very, very small, but never touches the y-axis, the x-axis, sorry. So we are ranging here from negative infinity to positive infinity because as the values are increasing, I'm showing you the positive infinity side now. And if I zoom it, you can see how the graph looks like for y equals 2 to the power of x. And see where your y-intercept is. Your y-intercept is at 0, 1. When x is 0, y is 1. So hopefully it made some sense. And then again, in this video, we talked about exponential functions and we graphed the very basic exponential function y equals 2 to the power of x. And I would give you a little assignment at the end. I would like for you to graph the function y equals 3 to the power of x and try and check the type of graph you get. And let me know in the comments section if you were able to get a graph that made some sense exponentially. And remember, you got to increase Miss Meta's views also exponentially as we are talking about exponential functions. All right, then I'll see you in my next video, and we'll continue exponential functions next up. You have a good one. I'll talk to you later. Bye.